Hi everyone and welcome back. In this lecture we're going to discuss selected material from chapter 3 and this chapter is focused on Pavlovian conditioning. Now we are talking about Pavlovian conditioning, so this all started with Pavlov's discovery. Ivan Pavlov was a physiologist and he studied digestion mostly in dogs. And his first step was the salivary reflex, so he was measuring saliva in dogs. And he developed a surgical procedure to measure salivary responses, and he won a Nobel Prize for this in 1904. But what he found was that salivation depended on the substance he used. And he also made the suggestion that it seemed as though these glands possessed a kind of intelligence. And then he found what he called psychic secretions. So repeated subjects that he used, he noticed that they began to salivate before they were fed. And his question was, how could this experience that they've had alter the reflex action of a gland? So how could we get a response before there's a stimulus? So he began recording all stimuli and responses. And here we'll take a look at a quick video just demonstrating how Pavlov did this.
Pavlov's aim was to discover what caused saliva to flow. He rerouted the salivary ducts to the outside of his dog's cheek so that he could collect and measure the spittle. Perhaps he thought the result of a fixed nervous reflex, like a knee jerk.
5 минут 42,5 секунды.
After taking many measurements of spittle, he confirmed that the dog's drool touched food. He called the response the salivation reflex.
4,5. Хорошая собачка. Я предлагаю...
To run into trouble. As his dogs became familiar with the experimental routine, they started to fill their cheek tubes before Pavlov had a chance to stimulate their tongues. The dogs were learning to anticipate food. Pavlov tried a new technique. He erected couldn't see what was going on. Before passing meat through the hatch, he introduced a stimulus that was totally
So through Pavlov's work that we just saw, he determined that there were two types of reflexes. The first of which is unconditional reflexes. So these are ones that are mostly hereditary, so they occur in all members of a species, and these are relatively permanent. So these would be things like, for example, if you were to touch something hot, you would innately jerk back. You don't need to learn that, that's just something you do innately. This would be an unconditional reflex. Whereas what he was seeing when his dogs were salivating before food was presented, this is what he called a conditional reflex. So this is a reflex that's acquired, either acquired or lost through experience. And this would vary greatly across members of a species, of course, because it is based off of that individual's experience. And we would say that this is mostly temporary. Now, taking a look more closely at these types of reflexes, so we look at an unconditional reflex. So this would be something that we have as a result of an unconditioned stimulus. So we would have an unconditioned stimulus presented, and this would yield some unconditioned reflex. So for example, with Pavlov's dogs, food would be the unconditioned stimulus. The dogs don't need to be conditioned to respond to food. They just innately do. So presentation of food yielded the unconditioned response of salivation. This happens without any kind of experience or anything like that. Again, this is unconditional, and this is basically innate responding. But the conditional reflex occurred when we have a conditioned stimulus that's yielding a conditioned response. So the sounds that Pavlov was playing, for example, those began to yield salivation because they'd been initially paired with the food presentation. So again, this is something that's requiring training, essentially, or pairing this conditioned stimulus with the unconditioned stimulus in order to get salivation to sound alone. But again, he wanted to pinpoint exactly what was causing the conditional reflex to be learned in the first place. Now, this is kind of what I mentioned in the last slide. This happens because you're pairing this neutral stimulus with an unconditioned stimulus. And eventually that neutral stimulus then comes to elicit a response or becomes a conditional stimulus. So if we're taking a look at the notation here, we have CS, which is conditioned stimulus, paired with a US, and this will yield some unconditioned response. Okay, so this would be in Pavlov's example. Conditioned stimulus would be the sounds that he was playing, paired with food, which is the unconditioned stimulus, and this is going to yield in the dog salivation. Now, if we take a look at this step by step how this would work, the neutral stimulus, NS, would be what the stimulus initially is before it's conditioned. So this would be the sounds that Pavlov was playing. So these don't yield anything in the dog initially. So he's playing these music boxes and ringing bells and such, and nothing happens. The dog does nothing. But then he gives the dog the US, which is food, and of course we have that unconditioned response of salivation as a response to that food. So then he begins to pair the sound boxes with the food presentation, and of course we still get salivation in our dog. But eventually, with enough pairings, the previously neutral stimulus, which again is the sounds, starts to become conditioned. So with repeated pairings, it starts to become a conditioned stimulus. And again, repeated pairings. So what we find eventually is that with presentation of the sound box alone, we get a conditioned response or salivation in the dog without the presentation of food. And this would never have occurred if it wasn't paired with this US of food prior. Okay, so how this is really occurring is the initial pairings with the food. Now let's take a look at
I'm
another
David, and I'm going to be
example.
testing Pavlov's theory of classical conditioning on my roommate Brian. The conditioned stimulus will be the sound effect.
That was easy.
And then I'm going to shoot him with this airsoft gun. He will soon learn the relationship between the sound effect and the shot before he gets too hurt.
That was easy. That was easy.
Ah!
That was easy.
Fuck.
That was easy. That was easy.
Alright guys, looks like Pavlov's theory worked.
Okay, first of all, I don't recommend that you do this to your roommate. But I think this is a good example of how Pavlovian conditioning really works. And, you know, it works, of course, on us and on every species. But if you take a look at this video, you can think about what is the neutral stimulus that becomes the conditioned stimulus, what's the unconditioned stimulus, and what's the unconditioned response. So if you think about that for a second, the actual gun that's shooting his roommate, the shot that the roommate feels. So when he's shot, that is going to be the unconditioned stimulus. So the gunshot, right? The air gun shot. And the unconditioned response is going to be to flinch. But initially, the "that was easy" button was a neutral stimulus, so the roommate didn't respond to it at all. But with repeated pairings, as we see at the end of the video, the roommate flinches or has a conditioned response to the "that was easy" button. Okay, so flinches without being shot with the air gun. All right, so that's a good example of how Pavlovian conditioning really works. So a few things to note about stimulus pairing. The first of which is that the pairing of the neutral stimulus with the unconditioned stimulus, so in Pavlov, for example, the pairing of the sound box with the food, this is happening independent of what the dog is doing. So whatever the dog is doing, it doesn't matter. Those two things occur paired together. And also with the roommate example I just gave you, regardless of what his roommate was doing, the air gun and the "that was easy" button occurred paired together regardless. So again, it doesn't matter what the subject's doing, the two things will be paired together and presented regardless of whatever the organism's actually doing. Now, also, the behavior that we see is a reflex. So keep in mind that the behavior we're seeing is a reflexive behavior. So salivation in the dog, flinching in the roommate, those are behaviors that are reflexes. And these are inherited reflex responses. But what's different about them with pairing is that now they're being elicited by a new stimulus that previously didn't elicit these reflexes at all. So again, this is done through pairing. This is why we see this behavior being elicited by a brand new stimulus. And here is just a quick Pavlov cartoon. Okay, now on to measurements. So now that we've talked about what Pavlovian condition is, how it works, and what type of responses we can expect if conditioning is successful, how do we actually measure if Pavlovian conditioning has occurred? So measures of Pavlovian conditioning. So something we can do is measure when we see response beginning or the latency of response. So if we take a look at this here, this would be our conditioned stimulus. So with the Pavlov example, this would be the sound box paired with the food presentation, and then of course our unconditioned response of salivation in the dog. Now, if we take a look at this here, so if over time with this pairing here, if we start to see a conditioned response of salivation before the US, so the sound box is being played, and before the US occurs, if we start seeing salivation, then we would say that we have some sort of conditioning that's happened. So, and again, latency is just referring to the time between this stimulus presentation here, so the sound box, and when we actually see a response of salivation. And again, if we see some sort of response of salivation to the sound box before the presentation of food, then we can say that there might be some sort of conditioning that's occurred there. And we do this in test trials. So this is what we are taking a look at when we're doing test trials. And we also call these extinction trials. These are trials in which we just present the CS only. So we just present the CS by itself, and this again is occurring after we've had some pairings of the CS with the US. So we present the CS by itself and no US, and we want to see what happens if we get a conditioned response or if we don't get anything. And if we get a conditioned response, then we would say that conditioning has occurred. Now moving on to what is actually measured. So what's our dependent variable? Well, we can measure intensity of response or magnitude, for example. So we can ask, how strong is the response? Is it a very large response or is it a smaller response? And in general, we would say the stronger the response, the more learning has occurred. And the smaller response, maybe not quite as much learning has occurred. And again, like I said earlier in the slide, we can also talk about latency or response time. So that would be, again, the interval of time between presentation of the CS and when we see the CR. So we can measure the time gap here. And then we can see what kind of response interval we're talking about, what kind of latency between that stimulus being presented and the response actually occurring. And we would say that the shorter amount of time that we see, there might be a stronger connection or more conditioning that's occurred. So if we have maybe a second or two between the presentation of the conditioned stimulus and the conditioned response, that's pretty good in terms of latency. So that's fairly short. So let's say if we did this again and we measured a 30-second time gap or something, that's a lot of time. So we might say that conditioning is quite weak in that case. Now we can move on to a little bit of a different type of conditioning, and we call this higher order conditioning or second order conditioning. Now, this is also can be referred to as second order conditioning as well, but this was discovered by Frolov, and this occurs after pairing a neutral stimulus with a conditioned stimulus. The neutral stimulus, which eventually becomes a conditioned stimulus, comes to elicit the conditioned response, right? So in this example, we have conditioned stimulus and we have a conditioned response. So for example, we could say that there's a light bulb that we're using and it's been previously paired with food and it is yielding salivation in our dog. But now we start with another neutral stimulus. So let's say it's a bell, for example. The dog does nothing because it's not been paired with an unconditioned stimulus. But what we can do for higher order conditioning is pair that neutral stimulus of the bell with the light, so the conditioned stimulus 1, and then what we would see is some salivation in the dog. Now if we continue this, eventually that bell is probably going to become a conditioned stimulus. So with repeated pairings, again, what we might see is something like this. So now we see with maybe presentation of the bell alone, we get salivation in the dog. So what's interesting about this and a bit different from what we've been talking about thus far is that the light bulb, which is our first conditioned stimulus, this would have been conditioned with food, for example, much like what we just talked about with Pavlov. But what's happening here in this second order conditioning or higher order conditioning is that this bell that eventually yields a conditioned response is never paired with food. It's only paired with that first conditioned stimulus. Now, variables affecting Pavlovian conditioning. So one thing that affects conditioning procedures is the passage of time. And we can take a look at different conditioning procedures that we would use. Now, the first of which we can take a look at would be actually delayed. So this right here, this one, this would be the one like what Pavlov used. So we'd have the sound box playing and then the presentation of food. Now notice that the conditioned stimulus of the sound box or bell ringing or whatever happens before the food presentation, but there is some overlap there, okay? And we know that this type of conditioning is quite effective. Now, similarly, we have something called trace conditioning. Now note that the conditioned stimulus is still occurring before the unconditioned stimulus, but there's a big lapse of time here between the two, so there's never any overlap. Now, something else that we see is simultaneous conditioning. So this is where we present the conditioned stimulus simultaneously with the unconditioned stimulus. And lastly, we have something called backward conditioning. This is where we present the unconditioned stimulus, and then we have a lapse in time, and then we present the conditioned stimulus. So it's occurring in the opposite order. Now, which of these are the most and least effective and why? Well, of course, we would say that delayed conditioning we know to be successful. This is probably the best one to use. Trace conditioning can be somewhat helpful, but again, with this big time gap here, the conditioned stimulus, while it is providing some information, perhaps that the unconditioned stimulus is going to happen, the more time you insert here, the weaker this connection is going to be, and the less effective the trace conditioning is going to be. Now, with simultaneous conditioning, because they're occurring at the exact same time, this conditioned stimulus isn't providing the subject with any more information than the unconditioned stimulus is. It isn't predicting that the US is going to occur because it doesn't appear or it isn't presented before the unconditioned stimulus. So it's really not very helpful. So simultaneous conditioning really doesn't work. And as you can imagine, backward conditioning doesn't really work either, because this conditioned stimulus is kind of a predictor that the unconditioned stimulus isn't coming or isn't going to be presented, because it's happening after the unconditioned stimulus has already occurred. All right? Now, some other things that affect conditioning, one of which is contiguity. Now, what is the role of contiguity in conditioning? Now, contiguity is referring to nearness in time or space, kind of like what we were talking about in the last slide. Now, if we're looking at the CS being near the US, so this would be something we're calling the interstimulus interval. So this is occurring between stimuli presentations. And if we say that the CS and the US are near each other in time, so the CS, we'll say that's the sound box, and the US is the food presentation. If we say they're near each other in time, we have a shorter ISI, or interstimulus interval, and that's going to make conditioning more successful because they're happening closer together in time. Now, if we look at trace conditioning versus delayed conditioning, which one has the shorter ISI? And there we go. So we have a larger ISI with trace conditioning, a smaller with delayed conditioning. And again, our general rule is the shorter the ISI, the faster the conditioning. However, remember that when the ISI is 0, so when there is no time between the CS and the US presentation, like with simultaneous conditioning, so the CS and US are presented at the exact same time, there is no ISI, or the ISI is 0. And what we have in that case is no conditioning at all. All right, so the general rule, the shorter the ISI, the faster the conditioning, except when the ISI is 0. Now, on to contingency. Contingency is referring to the prediction. So, if this, then that. And what we should see with conditioning is if the CS occurs, then the US will follow. So the CS should predict the US. So the US should be contingent upon the CS. Okay? Now, if we're looking at the test of contingency, we can look at Rescorla. And he tested 3 groups of rats, and all of them received the same number of CS-US pairings. Okay? Now, he had a highly contingent group, a medium contingency group, and a low contingency group. And all of these groups, again, got 10 CS-US pairings, so all the same. But then the high contingent group got 0 trials in which the US was presented alone. So the US in this group never occurred without the CS being paired with it or occurring before the US. The medium contingency group had 2 US trials by itself. So they had 10 CS-US pairing trials. But then they had 2 US trials without a CS. And then in the low contingency group, this group had, again, the 10 CS-US pairing trials, but then they had 4 trials in which the US happened by itself with no CS presentation. So as you can see with the low contingency group, what this is saying is that the US being presented is not as contingent upon the CS being presented because the US is occurring sometimes by itself. Whereas with the highly contingent group, the US is never occurring without the CS. Now here's the data that Rescorla recorded. Now, as you can imagine, we're looking at strength of conditioned response, and we would predict that if contingency is important, the high contingency group should have the more strength of CR, and that is what they found. They found a lot more strength in the conditioned response with the highly contingent group, and really no conditioned response with the low contingent group. So pretty much exactly what you would predict. So in general, more unpaired US presentations yields less learning because the US is sometimes occurring without the CS, so it's not as contingent on, the US isn't as contingent on the CS, so there's less learning that occurs in general. And what this tells us overall is that the CS-US contingency is important. Conditioning isn't just a matter of pairing stimuli, it's also a matter of does the US occur outside of the presence of the CS. That matters as well. Now, more variables that affect Pavlovian conditioning. The first thing we can look at is stimulus intensity. And in general, we would say more intense stimuli condition more rapidly. So, for example, light bulbs, if we're using those as a neutral stimulus that will become a conditioned stimulus, a brighter light bulb will probably condition more rapidly than a duller light bulb. However, we do have to keep in mind that extremely intense stimuli that interrupt learning or cause pain will have the opposite effect. So you don't want anything that's too intense that actually hurts the subject. Also, number of pairings, generally more is better. So more pairings of the conditioned stimulus with the unconditioned stimulus will have a stronger relationship that develops there. And we also see what we call a nonlinear relationship between the number of pairings and the strength of the CR. So here we have strength of CR here as a function of number of trial pairings. And what we get is something like this. So we see what we call a decelerating curve. So we see more learning early. So that's why we see a very steep slope here and less learning later. So while we say in general more pairings is better, the amount of improvement that we see at a certain point is kind of negligible. So you got to kind of pick a happy medium here. Somewhere in the area of, in this particular example, maybe 24 pairings would be great. So in general, the more pairings you can do, the better, but there is a point at which we're going to hit a plateau. Now we take a look at variables about an organism that affect conditioning. So age, for example, of the organism. So if we look at eye blink conditioning, and we look at it in children, young adults, and the elderly, what we're going to see is that young adults are going to respond the most, followed by children, and then finally older folks or elderly people are going to respond the least. And we can see an example of that here. So we have percent conditioned responses as a function of conditioning. And what we see is that the elderly people aren't really responding that much to eye blinking. But we see more eye blink responding with the young adults and with the children. Okay, so age in this example is somewhat affecting conditioning. Temperament can also play a role. For example, individuals, of course, as we know, vary greatly in temperament. Some people are much more excitable, some people are much more sedate, and there's a large range in between that. But in general, we see more conditioning in more excitable people and less conditioning in sedate people. So if we take a look at stress and anxiety, and we can see this, we're measuring this as a function of relaxed versus anxious students. Now, we're looking at this in terms of how students actually rated on a neuroticism scale. And that's how that they were categorized into anxious and relaxed students. Now, if we look at how this is as a function of trials here. So this is conditioned responses as a function of trials. And what we see is with more trials of experience, the anxious students are giving more conditioned responding. So we see more conditioning in the anxious students and less in the relaxed, even with repeated numbers of trials. All right, so these are just a few variables about the organism that we're studying that can affect conditioning somewhat. Now, to summarize what we've talked about thus far, what affects the rate of Pavlovian conditioning? How predictive or contingent the US is on the CS. So it needs to be predictive, okay? Contiguity, so the CS needs to be close in time to the US. If it isn't, then we don't see as much conditioning. And also contingency. If CS, then US. If no CS, then no US. That should be the rule. We should never see the US occurring outside of the CS. All right? So if all of these things are strong, we should see a lot of conditioning occurring. Now, moving on to Pavlovian phenomenon. The first thing that we can see is called overshadowing. Now, overshadowing occurs when we have one CS component that's more effectively conditioned than the other. Now, if we take a look at the procedure, let's say, for example, that we're going to train a compound stimulus. So we're going to train a light and a buzzer together. That's our compound. And we're going to pair that with meat. And what we should get from that is salivation, right? If we're doing this in dogs or, another similar type of species, we should get salivation. Now, there would be our compound stimulus, so that would be our light and our buzzer, and it's paired with food, and we should get salivation. Now, in tests, we would test each component of the compound stimulus by itself to see if both have the same conditioning capacity. So first we test the compound and we get the same amount of salivation. So we can say the compound is effectively yielding salivation, so it's a conditioned stimulus. And then we present the light by itself and we see a good amount of salivation. And then we present the buzzer by itself and we see a lot more salivation. So what we see here is that the buzzer was more conditioned than the light, even though they were presented together as a compound. So in this particular example, the buzzer overshadowed the light when conditioning was happening. So the light did get some conditioning strength, but not as much as the buzzer. The next thing we'll look at is called blocking, and this is more looking at how previous pairings of a CSUS affect new pairings. And this is a study done by Kalman in '69. So he used a tone, which would be the first conditioned stimulus, paired with shock. So, of course, tone paired with shock would yield some sort of a freezing response. And then they used a light as the second conditioned stimulus and the tone, so they paired the two together as a compound and paired that with shock, just like that. And then they wanted to test it by presenting the tone by itself and the light by itself and test them individually to see what their conditioning properties were. And what we see here is that with the tone, there is still a conditioned response, but with the light, there is no conditioned response. So what occurred here is that prior CSUS pairings, in this case, interrupted the new SS pairing learning. So the previous pairing with the tone and shock kind of prevented the pairing of light and shock. So the light never gained any conditioning properties. And again, this is due to the previous pairing of the tone and shock together. Now moving on to latent inhibition. This asks the question of how will previous experience with a neutral stimulus affect conditioning? Now, the question being, does prior experience with a stimulus affect learning when it's paired with a US? And Loblow took a look at this in '65, and they used 3 groups of sheep in their experiment. And they used a tone presentation, and they presented a tone alone either 0 times, 20 times, or 40 times, depending on the group. And then they paired the tone with a US, and we'll say food, for example. And we're looking at percent conditional responses, so the number of conditional responses is a function of days. Now, what's interesting is that we see here is the group of sheep that had the tone presented 0 times by itself, then 20 times, and then 40 times. So what we see in this case is that this previous exposure to a stimulus interfered with conditioning. So the sheep that were exposed to the tone 20 and 40 times before it was actually paired with food, that affected its predictive ability of the food when it was paired later on with food. This is why we say in general novel stimuli or new stimuli are most easily conditioned. So the last one we'll look at is called sensory preconditioning. And in this example, we're looking at how will previous pairings of 2 neutral stimuli affect later conditioning. And this study was done by Brogdon in '39. And what they did was pair a light with a tone and measure any kind of response to that. So, for example, we pair light tone and we repeat. And then we pair tone with shock. And then, of course, we see an unconditioned response, maybe a freezing, for example. And then that pairing is repeated. So then, of course, we present tone by itself and we get that conditioned response of freezing. And then we wonder, what about the light? The light was never directly paired with shock like the tone was, but the light was previously paired with tone in the very beginning. So would we get some sort of conditioned response to the light by itself? And what Brogdon found was that there was some condition responding to the light by itself. And this is what we call sensory preconditioning. This is what happens when we have a neutral stimulus, like the light, that was previously paired with another neutral stimulus, like the tone. And it might elicit a conditioned response if the neutral stimulus, too, is later paired with the US. So, for example, the neutral stimulus of the light was previously paired with the second neutral stimulus of the tone. And then the tone was then paired with shock. Now, we got a conditioned response to the tone by itself, but because of the light's previous pairing with the tone, we see the freezing response or condition responding to the light as well, even though it was never directly paired with shock. And again, this is called sensory preconditioning. Now if we take a look at the slide, we're going to just compare all of these 4 procedures that we just went through briefly. So if we look at overshadowing first, in overshadowing, remember we have that compound stimulus. So we have, let's say, a light and a tone, for example. And then they're paired together like a compound, and they're paired with the unconditioned stimulus. And of course, over time, with many pairings, we get a conditioned response. And then the individual components of the compound are tested by themselves. And what we find is that one might yield a lot of conditioned responding, while the other one doesn't yield as much conditioned responding. So what we say in that case is that the one that's getting more conditioning responding is overshadowing the other component of the compound. Now in blocking, what we see is we have a conditioned stimulus paired with a US and yielding conditioned responding, which is salivation, of course. And then we introduce a new stimulus and pair it with that conditioned stimulus. So we make a compound, and we continue pairing that compound with the unconditioned stimulus. And then we test the 2 different components. And what we see here is that the original CS still gets a fair amount of conditioning or conditioned responding, but the new component that was added in later doesn't get any conditioned responding. And what's happening is that original conditioned stimulus blocked any kind of associative property that the new conditioned stimulus would gain. So no conditioning occurred to that second conditioned stimulus that was added in. Now on to latent inhibition. Here we have a stimulus that's presented by itself for a while, and basically no response from the subject is yielded as a response to this. So it's just presented for a while by itself. And then that same stimulus is then paired with food, and we get some sort of conditioned responding. And then later on, we test it just by itself. But what happens here is that because that stimulus was presented by itself for a while before it was ever paired with an unconditioned stimulus, we see that conditioning just in general happens slower because of this initial exposure to the stimulus by itself. And the last one we'll look at is sensory preconditioning. So we have initial pairing of 2 stimuli here, and then we take one of these stimuli in the compound and pair it with an unconditioned stimulus, and we get a conditioned response. And then later on, we take the previous component of that compound and present it by itself, and we see some sort of conditioned responding. And this is a result of sensory preconditioning. This is a result of this component of the compound being paired with the other component that got actual pairing with an unconditioned stimulus. Okay? The last thing we'll discuss is extinction, and what we know is that once established, a conditioned reflex can endure indefinitely if the CS and US are paired together on occasion. Now we know that once we're training a reflex, if we're trying to get conditioned reflexes to occur, we want the CS and US to be paired together always, and we want many pairings. But once we get the conditioned reflex occurring, we can pair the CS and US together on occasion to maintain that behavior. But in extinction, we present the CS alone, and over time this will reduce the amount of conditioned responding we see. So in Pavlov's example, Pavlov would show the dog food, but he wouldn't feed the dog. And over time this decreased salivation in the dog over trials. And again, this is called extinction. Now keep in mind that extinction is not forgetting. The two are quite different. Forgetting is a decrement in behavior over time without practice. So if you, for example, learned a trait you haven't practiced in a while, you go back to do it, you're probably not going to do it as well as you did. This would be what we would kind of call forgetting. Extinction behavior is different. This is just a decline and eventually no response as a function of there not being really a reason to respond. Now, if you're not getting food for performing a certain behavior, or if you see a stimulus that's occurring that's not predictive of anything, there's no reason to respond to that stimulus anymore. So forgetting and extinction are quite different. Now, following an extinction period and a delay, if a CS is presented alone again, you might see a jump back up in conditioned responding. So if we have strong conditioned responding, we introduce extinction, and which is again the CS being presented by itself. And then we see a large decline in condition responding to the point where there's really no condition responding. And then we introduce a delay where nothing is being presented. And then we present the CS again by itself. We might see a jump back up in condition responding. And this is what we call spontaneous recovery. And something to note is that we have to extinguish the CS more than one time in order to say that there is spontaneous recovery. So you can't just present the CS one time without the US and then have a delay and then present the CS by itself again and see some condition responding and say that's spontaneous recovery. It's not the same thing. So we have to extinguish the CS more than once to see this occurring. So that's all we'll talk about in this chapter this week. I hope you enjoy this material. Take a look at this chapter very carefully, and I'll be back with you next week with chapter 4. Have a great week, guys.